in my mind, I think you're all award winners.
Miss Ford, you started like getting choked up.
You look at these kids that come in and people wonder, oh, can they make it if they're evil? And then look at them. Look at how they fly up.
That made me cry.
It's amazing. You remember that class, sir.
I was in that class. Sure was.
All right, so here we go. Here's the deal. What this given stuff means is, think of A as being like apples. So the probability you like apples is 0.6. That's what this means. The probability you like A is 0.6. The probability you like bananas is 0.5. And the probability you like apples and bananas, this is the mathematical symbol for intersection, or and, the probability you like both is 0.2. Now, when you're filling in your Venn diagram, we talked about this the other day, that's where you start. You start with the overlap part. You can't put 0.6 here. It says the probability I like apples is 0.6. Well, that means the whole apple circle is 0.6, right? So you don't dare start with 0.6 here. But you know the overlap area, the football, is 0.2. Well, what does that mean about this then? 0.4. Because the whole circle is 0.6. And what does that mean about here? 0.3. Now, remember, these are probabilities. That P there means probability. They're not raw numbers like we had before, like 16 people like jazz and 12 people like country. No, these are probabilities. So what do we know about probabilities? They have to add up to 1. Well, wait a minute. These add up to 0.9, which means there's a 0.1 or 10% of the people don't like apples or bananas. Does that make sense to you? Now, based on that Venn diagram, we're going to answer these questions. These are the actual questions there, okay? This means not. So this says, what's the probability that I like apples and I don't like bananas? Well, where am I here if I like it? Colin, what are you doing?
I was just checking the
Okay. Okay, well, I already said we're going to lunch at noon. Put your phone in your backpack. You know it makes me twitch. It needs to be out of temptation. All right, so I like apples and I don't like bananas. So what's that number? That's these guys right here. They like apples, but they don't like bananas. So they're just in the A ball, so that's 0.4. What's this?
0.3.
I don't like apples, but I do like bananas. So that's right here, that's 0.3. What's this?
0.1.
I don't like apples, remember that means not. I don't like bananas,
0.1.
and I don't like apples. That means I'm right here, isn't it? 0.1. Now, this one is new to you. It says, what's the probability? I'll write it out. What's the probability of A given B? Okay, that's what that bar there means. And luckily, I mean, you could think your way through this, but there's a little formula that makes it go a lot faster. The formula for this is the probability of A and B over the probability of B. So in other words, if you take all the people who like bananas, what's the probability that if you reach in and pick one, you'll get somebody who likes apples too? Well, the probability of A and B is right here.
0.2.
And what's the probability somebody likes bananas? The total probability of liking B? 0.5. So the answer is 2/5. Or if you type that in on your calculator, 0.4. So our formula for this, when you see this bar right here, that's pronounced given, it's called conditional probability, given, but we say as A and B, so both A and B over the probability of B. All right, now I got another one. I apologize in advance, I got some of the letters wrong. Somehow I threw B's in there, I noticed, and they're all supposed to be C's and D's. So change all the B's to D's. All right, so here we go. Let's see if we can fill in our Venn diagram. Here's the given. This is the given right here. So where do we start?
0.35.
In the middle, 0.35, right here. Then we can build out. What goes here? 0.40. Don't these have to add up to 0.75? Is that right? And then what goes over here? 0.05, right? 0.05. Because doesn't this have to add up to 0.4? And we already have 0.35 in here? Right? Okay?
So it's 0.2 outside?
Well, I don't know. What do these add up to? 0.8? So it would be 0.2 out here, yep. Remember, if it's a probability problem, if you got these P's, it's a probability problem, and it has to add up to 1. The box has to add up to 100%. All right, what's this one? What do you think? This says I like carrots, but I don't like donuts.
0.4.
Isn't that right here? 0.40? This one's not. So I'm in the C ball, but I'm not in the D ball. 0.4? All right, what's this one? 0.05. I like donuts, but I do not like carrots. So that's me right there. What's this? That's 0.2. I don't like either one. I'm not in the C ball or the D ball. And then what's our formula for this now? This means, what is the probability that I like donuts given I like carrots? So when we evaluate that, we do the probability of both D and C over the probability of C. So what's that gonna be? The probability of D and C is 0.35.
Divided by
And the probability of C is 0.75. Now when we answer that, that's the setup. That will give us the right answer. We have to reduce that. And how you reduce it is up to you, but I want to remind you, your calculator will do it for you. So if you do 0.35 divided by 0.75, and then hit math, the regular math button, and frac, it says 7/15. So you can always reduce your fractions on your calculator. So I just typed in 0.35 divided by 0.75, hit my math button, hit option frac, hit enter, and it gave me the answer. Okay, Ollie?
For that kind of answer, do we want a fraction?
Yes, I don't want, I want a fraction unless you can write a decimal that's not rounded off. If you have to round it off, I don't want it. Okay, so if it came out to be 0.83, fine, 0.83 is fine. But if you have to round it off, like this one needs rounded off, then don't do that. Okay, all right. Hold on, I know you're starving to death, but you got a few more problems to do. All right, number 10, A. If it rains tomorrow, the probability that Joe will do his homework is 40%, it doesn't rain, it's 10%, give me the probability of rain, find Joe's probability of doing homework. And this is a little complicated because Joe doing his homework depends on whether it rains or not. Would you agree with that?
Yeah.
When we have situations like this where the probability of doing something depends on the probability of something else, the easiest way to visualize that and get an answer is to build what we call a tree diagram. So you've probably all seen a tree diagram before. And when we build it in this situation, we're gonna have two tiers because you got raining and you got homework. You got two things going on in the problem. The last tier, the tier at the bottom, always answers the question. So the question says, find Joe's probability of doing homework. So homework or no homework is gonna be the bottom tier. This is gonna be rain or no rain. So the first thing that's happening in the problem is it's either gonna rain or not rain. And then Joe's either gonna do the homework or not do the homework. Okay, have you seen tree diagrams before? So here we are at the beginning. So the first thing that has to happen is it's gonna rain or it's not going to rain. And then, based on that, Joe's either gonna do the homework or not do the homework. All right, so let's start filling in some numbers. Where do you think the 0.4 or the 40%, the first number in the problem is 40%, where do you think that goes? Right here. Because it's raining and there's a 40% chance that Joe's gonna do his homework. Now, what's this number?
60.
That's gotta be a 60. Because if there's a 40% chance he does it, there's a 60% chance he doesn't. Now, I'm saying percent, I'm writing decimals, that's not confusing anyone, I hope. All right, next number is 10%. If it doesn't rain, the probability of doing homework is 10%. Where does that go?
No rain.
No rain.
Right here, right? So this is 10%, and this then would have to be 90%. The probability of rain is 30%.
So going to rain is 0.3.
30% to rain and 70% not to rain. Everybody agree with that? Now, we want to know the total probability of him doing his homework. Now, he can do his homework two different ways. He can do his homework if it rains, or he can do his homework if it doesn't rain. Well, let's look at this branch first. This is rain and homework. So I'm going to take 0.30 and 0.40 and multiply them. Because to be on this branch, it has to rain and you have to have homework. Right? So I don't know, what is that? I put that on my calculator. 112. Now what am I going to do?
Then you do
I'm
the
gonna do the same thing over here, only now it's not gonna rain, and he is going to do his homework. So that's gonna be 0.07, I think.
Yeah.
Use your calculator to help you with your arithmetic. So here I've got a 0.12, here I've got a 0.07. I want the total probability of his doing the work. What am I gonna do with those two numbers?
You add the
I add them. Because boys and girls, it's this or this. And whenever it's a work, we add, you want the total. So the answer is 0.19. So there's a 19% chance that Joe's gonna do his homework. All right, let's read the next one. Now we're doing noodles and salad. So here's my tree diagram. You gotta figure out, basically we got noodles and salad. That's what we've got in this problem. You gotta figure out if you put noodles here and salad here, or vice versa. So I told you, always look at the question. The question is, what's the probability they'll serve salad? So this is gonna be salad and no salad on the bottom. Then what's gonna be on top? Noodles
or no noodles.
or no noodles. You that easy, kids. It looks like a really hard problem, but it's pretty easy. All right. Start filling in the numbers, and I'll fill them in and we'll see if we match. You gotta have each of these branches, each of these lines here has to have a number on it, a decimal. So see if you can put decimals on all these. Did you put your 0.8 right here?
Yes.
And your 0.5 over here? And then we remember that each of these B things has to add up to 1. Salad, no salad, that's it, gotta be 100%. So each of those adds up to 1. Where did this 0.2 come from? Alexis?
For 2 school weeks, I have 2 noodles and 8 without, because it's 10 days.
Okay, so basically I'm serving noodles 1 out of 5. Right? What's 1 divided by 5 on my calculator? 0.2? That's where that came from. That's the probability I'll serve noodles. Okay, so what's the question? Find the probability we'll have salad. Well, we can have salad this way, which would be 0.2 times 0.8. Or we could have salad this way, which is 0.8 times 0.5. Everybody following along there? I got 0.56 as my answer. Did you?
I did.
All right, one more, try it on your own, see if you can get it done. Are you lacrosse players gonna be offended if I use LAX?
That's what I use.
Well, good for you, because somebody yelled at me the other day when I did it. People just like to yell. Is this how you have your chart started?
Yes.
Don't just copy down my numbers, make sure that you are, that that's making sense to you. I got 0.578,
I got that.
you got that? Other people got that too, 0.578? Okay, perfect. Anybody have a question about that? All right, I'm gonna do one quick review problem. This is not on your quiz that we're having today, but it is a problem that we probably need to, touch base on. So let's see if we can remember how to do this. Let's say we're going to take a, 6-question multiple choice test. Each question has 4 options. You know, A, B, C, D, it's multiple choice. And we're totally guessing. We don't know, maybe it's in like German or a language we don't know. So we're totally guessing. What's the probability we get exactly 2 correct? Okay, so do we understand the question now? All right, does anybody remember how to do this? It's been a few days ago. Anybody remember how we proceed? Any pieces of it? Any piece of it that you remember? That?
Would it be, well, something C something.
Okay, so he knows
Time.
combinations are going to be a part of it. Yeah, Gavin?
I was gonna say, don't we put like the right and wrong?
Okay, so we got this going on, but then we also, another piece of it is, we have the probability of getting it right and the probability of getting it wrong, because every time I guess, that's what happens, right? I either get it right or I get it wrong. Okay, do you know what those are? Don't get ahead of yourself. Do you know what these are? These probabilities? Yes, you do. It's a 4, I'm gonna guess, yeah?
No.
Yeah, so getting it right would be 1/4, and getting it wrong would be 3/4. Right? How many do I wanna get right?
2.
So I'm gonna put a 2 on the right, and then if it's a 6-question test, I'm going to put 4 on the wrong. Everybody okay with that? All right, now what about the C thing? Because the C thing is a definite component of it. So what do you think? Jeff, try again.
62.
Yep. What is your objective? There are 6 questions and you want to get 2 of them correct. Right? Which, by the way, is the same as 6C4. Because if you're gonna get 2 right, you're going to get 4 wrong. So if you did 6C4 here, it would be the same exact answer. All right, we're at going to lunch, so we type it in. I want everybody typing it in, getting the right answer, and then we go to lunch. Actually, it's a better chance than I thought. You're only getting 2 right, so that's not too good. Come up with.
I got 2.2 on that.
Yeah, it's just about 30%, it's 0.297 or something like that. All right, if you got that, you can go to lunch, you need to get back at 12:30, they're gonna kick you out, you need to get back at 12:30. If you didn't get that, bring your calculator up here, let's get it straightened out before you leave.
Back here at 30 or
30. What does that say? I said back for weeks. Oh, okay. Well, I knew you were getting words and stuff, I wouldn't worry about it. You did what?
I did watch the video. He wants to go to this.
No, it's, oh gosh.
Yeah, that's what's on, that's, no, this is what's on our quiz for today, yeah. What we're doing here is just a review problem, yeah.
You didn't say that particularly on the video, so